In this video, we're talking about the domain and range of a function. So the domain of a relation, which is just a relationship between something, always belongs on the horizontal axis. And it's all the set of values that it can take. And we usually donate that with x. The range is the set of values which the vertical axis can take, and we usually denote that as y. So in the previous video, we talked about this x-axis being our input. Well, our input is also our domain. In our range, we said our y values is also our output. So our range is also our output. Okay. So in this graph right here, you can see that the lowest y value, or lowest output, or lowest point of the range, we could just say is 2. And the highest part of the range, we could just make up and say it's 6. Okay? So that would be from 2 to 6, the range. And then for the domain, we could say that it's, I don't know, we'll say it looks like it's 2. And say that this is, I don't know, we'll say it's 8. So our domain is from 2 to 8. Okay? And every value in between 2 and 8. All right, let's look at some notation here. Okay, there's a few different ways you might see this described with some mathematical notation. Let's say that we want to describe and say that x is greater than or equal to 3. So the way that we would say this, guys, is when it's in set notation like this, we'd say the set, that's what this right here means, the set of all x such that x is greater than or equal to 3. Now, bracket notation is saying the same thing. These are the same thing, but it's written differently. This is saying x is an element such that, now this right here, that bracket, when it's facing inwards, that's including 3. So this guy right here, this guy right here, that little bracket, when it's including, that's saying it's equal, it's including 3. When you have a bracket facing out like that, that's excluding. So including and excluding. So down here, this is an example of something that is excluding both negative infinity and 2. Okay. Anyways, back here. So notice that you guys, you'll learn, but you can never include infinity. It's impossible to say, yeah, whatever the last number is, if it goes on forever and ever, you can never exclude it. So if it's infinity, it's always excluding. Okay, so this is what it would look like on the number line graph. Right, notice you're filling in. If it's including 3, you fill it in. And then you indicate with an arrow moving the direction. And here it is, the set of all x such that x is greater than or equal to 3. In this next one, notice that we have, you should get used to saying, you should be able to say this out loud. The set of x such that x is less than 2. So that means that we're not including 2, or because we have it's less than 2, it's negative infinity. Notice that if I'm not including something, the circle will be open, the dot will be open. I can have this closed interval in this third box. Notice that I'm not including 2, but I am including 1. So notice over here, I have enclosed 1, and I have left 2 open. Everything in between. Last example here is if I have x, the set of x, such that x is less than or equal to 0. Or x is greater than 4. What would that look like? Well, it can be x less than 0 or equal to 0. And it can be x greater than 4. So you should be familiar with this notation, all of this notation, words, number line graph, bracket notation, and set notation. All right, let's look at these graphs here. So if we're just given these graphs, which we often are, and we're just asked to state the domain and range. In A, the domain is x is less than, it says the set of all x values such that x is less than or equal to 8. Well, why? Well, remember, the domain, guys, is just the x-axis. So notice how far left and right does my curve go? Well, my curve only stops, it only goes as far right as 8. And you can see that this means that it keeps going on and on forever and ever. Now, it looks like it keeps going up and up forever and ever, but because it's going up and not directly up, it's also going out to the left forever and ever. So that's why it's anything less than or equal to 8. Anything less than 8, okay? The range, on the other hand, is just looking at the y-axis. So almost if you could kind of remove, the x-axis when you look at the range, it would be really helpful. But here I have the set of all y values such that y is greater than or equal to -2. So the question is, how far up and how far down does it go? Well, you can see that it stops here, and because it's filled in, it's including -2, and then it keeps going on and on forever and ever, so it's going to keep rising. So it's everything above -2, including -2. Okay? All right, let's look at this next one. Again, I'm given the graph. They're asking for the domain and range. Domain is everything left and right. How far left and right? You can see here that it's going to keep going to the left and to the right forever and ever. So the way you would indicate that is x is an element of the real numbers. The real numbers is every number that you can think of. The range, again, we're dealing with up and down here. How far up and how far down? You can see that it's going to go up forever and ever, but it stops here at -1. So everything, including -1 and above -1. There it is with graphs. Now, we're also going to be given functions, algebraic functions, just to look at. We should know what these look like on a graph. We should know the domain of each function. So the square root function, guys, remember that in general, the square root function, if I had the square root function, x has to be greater than or equal to 0. So whatever's inside here, the domain, whatever x has to be, the x minus 5 has to be greater than or equal to 0, so x has to be greater than or equal to 5. So the domain here is greater than or equal to 5. Now, if 5 is what's going to make this 0, 5 minus 5 equals 0, and that's the smallest input you can put in there, and that will be my smallest output. So 0 is my smallest output. So my domain is y, the set of y values, such that y is greater than or equal to 0. And if you were to graph that, you could see the biggest y, the most it goes up or down, the most it goes down is at 0. And it continues to go up forever and ever. Okay, for B, immediately I should think, okay, if I have a fraction here, I know I can't divide by 0. So x cannot be 5. Why? Because if x is 5, then 5 minus 5 is 0. I can't have that happen. So you can see here that my domain is anything, the set of all x values such that x cannot be 5. If you say this implies that x can be everything else just by writing this. Okay? if, for example, we know that this function right here is never 0. Now, how do I know that? Well, how do I know, Mr. Josh, that this function is never 0? Well, I know that y is never 0 because just look at this function. For order of fraction to be 0, you have to have 0 over some number. Some number, okay? Well, we have a 1 in our numerator, so it will never be 0. So our range can never be 0. So over here, you were graph this. Notice right here, a range could never be 0. There's no crossing there of that green curve. The last one, I have 1 over square root of x minus 5. Now, think about this. It's kind of a combination of b and a, right? If we look at the domains of each one, we have to take in consideration the domains of each one. So we know that in a, square root of x minus 5, that had to be bigger than or equal to 5. We know that 1 over x minus 5, that our denominator couldn't be 0. Okay? So, down here, I know that x minus 5, I know that if my denominator can't be 0, that means I can't include 0, I can't include 5 like I did up here. If I included 5, then I would plug 5 in, 1 over square root of 5 minus 5, and that would be 1 over square root of 0. And while I can have the square root of 0 that's equal to 0, that's okay, I can't have 1 over 0, so that's not okay. So we have to change our domain to x is greater than 5. Notice you have to pay attention to both domains. Okay? And same thing with the ranges. It's always positive because our square root is going to make it positive. And it's never 0. Why is it never 0? It's never 0, again, because the 1's in the numerator. Simple as that. Okay? That's it for